All right, let's talk about the determinant of a 2 by 2 matrix. The concept of determinant of a matrix is associated with a square matrix. And a square matrix is a matrix that has the same number of rows and columns, meaning that you can only find the determinant of a 2 by 2 matrix, a 3 by 3 matrix, and so on. So in this video, we want to be specifying majorly on that of a 2 by 2 matrix. And you can see a matrix A being defined as what you can see right here, with the elements being given as you can see. Now, this is A11, meaning that this is the element of row 1, column 1. This is the element of row 1, column 2. This is the element of row 2, column 1, and row 2, column 2. I'm sure we remember that this is the row 1, this is row 2, this is column 1, this is column 2. So the concept of finding the determinant of a 2 by 2 matrix is quite easy and very simple to resolve. All you have to do is to go on to multiply the leading diagonal, which is always that diagonal that stems from the top left, this is the top left, to the bottom right. This is the leading diagonal that has been specified as seen. So A11 and A22 is the element of the leading diagonal, while we have the other diagonal as this. So we have A21 and A12 as the element of the other diagonal. So you can see right here, the symbol we have here, A in between two straight brackets, two line brackets, is what we always use to signify the determinant of a matrix. So anytime you see a question telling you to find something like this, or it could be something like this, this is always synonymous for you finding the determinant of the matrices that is being specified inside the line bracket. So to find the determinant of a matrix, all you have to do is to multiply the element of the leading diagonal as A11 times A22, what we have right here, and subtract the element, the multiplication of the elements of the other diagonal, A21 and A12. And that will give you the answer you're looking for. Let's try an example quickly. So we have a matrix A given as shown in the video below, in the video above. We can see that the matrix A has this leading diagonal. So therefore we can define the determinant as 2 times 5, which is the leading diagonal, minus 4 times 3, which is the other diagonal. This will give me 10 minus 12. This will give me minus 2. So therefore, I can say that my determinant of A is given as minus 2. So looking at this other example, you can see that to find the determinant of A here, what we have to do is to multiply the leading diagonal, that will be 8 times 2, and subtract the other diagonal from that. That's 4 times 1. So we have 16 minus 4. This gives me 12. Therefore, I can define my determinant of A to be equals to 12. Now, there are several applications of matrix determinant that I would love to show to you. It's a very versatile aspect in matrix, and you need to know how to apply the knowledge of determinant of a 2 by 2 matrix to several questions. So let's see more questions on this. All right, look at this question you have right here. Now, I told you already that when you have two line brackets in between a matrix, the meaning of that is the determinant of that matrix. Now let's look at how we want to resolve this. You were told that the determinant of this matrix right here is 4. You're then told to find the value for y. From our knowledge of matrix determinant, all we have to do is to try to find the determinant of this matrix. So we have the determinant of this matrix being the multiplication of the elements of the leading diagonal, that's y times 4, minus the multiplication of the other diagonal, the elements of the other diagonal. So what we have here, and don't forget we were told that the determinant was equals to 4. So what we have here is 4y minus 16 equals to 4. Then we have 4y equals to 4 plus 16. Then 4y will be equals to 20. And obviously dividing both sides by 4, y will be equals to 5. So we can see that from our knowledge of matrix determinant, we've been able to find the value of y. All right, let's see another application of a 2x2 determinant. Now, you can pause this video right here and try to attempt this question. All right, you can drop your answer in the comment section. Looking at what we have right here, this is a question you have to study carefully. You're told that a matrix A is given as this, and matrix B is given as what you have right there. Then this is the condition that was set. You're told that 2 times the determinant of A is equals to the determinant of B. Then you are then told to find the value for x. So the concept to solving this is for you to go on to find the determinant of A and the determinant of B. That's the first and foremost step to take. So let's try and resolve the determinant of A. The determinant of A will be 2 times 4 minus 3 times 1. That would be 8 minus 3, which will give me the value 5. Then we go on to solve for that of B, which will obviously be 5 times 2x minus 6 times 0. This will obviously give me 10x minus 0 times minus 6, 0 times anything will be 0. So I have the value of 10x as my response there. Now, let's remember the condition that was set for us. And that was the fact that we have 2 determinant of A being equals to the determinant of B. So we can go on to say that 2 times 5, which is the determinant of A, is equals to 10x. Now from here, we can see that resolving this, we would have 10 equals to 10x. Dividing through by 10, our x will give us 1. So therefore, using our knowledge of matrix determinant, we've been able to resolve this question, and we've gotten our value for x to be 1. So x is therefore equals to 1. Now you can go on to always confirm your answer by fixing your value for x as 1. If you fix in your value of x as 1 in this equation, in this place, that will be 2 times 1. That would make it 5 times 2 minus, this will give you 0. That will be 10 minus 0. So our determinant for b will be 10. And we have gotten our determinant for a to be 5. Obviously, looking at this, determinant of a as 5, determinant of b as 10, it confirms the condition that 2 of the determinant of a equals to 1 of the determinant of b. Therefore, we can confirm that our answer is very correct. All right, this is the question I would love you to resolve. Give me your answer in the comment section, finding the value for x. All right, thank you guys for joining. I hope to see you in the next video. Bye-bye.